now we're going to move on to looking at some examples. So our first example gives us two functions, and what you'll notice is that in this chapter you're going to be looking at all the different functions from this course and combining them in some form, okay, whether it's adding, subtracting, multiplying, dividing, or looking at composite functions, which is our next lesson. So back to the example. So we have given f of x equals the square root of x minus 3, so we have a root function here. And g of x equals 1/2 x plus 1, that's a linear function there. First we're going to find the product of the two functions, so we're looking at f times g of x. And so I'll start by multiplying the two functions together. So I have the square root of x minus 3 multiplied with 1/2 x plus 1. So what you'll notice is that in this case I cannot simplify this further, and that's mostly because I have a root function and a linear function, and algebraically the bases cannot be combined. Okay, so we'll leave it the way it is. Part B asks us to look at f times g of 12. So what that means is if x is equal to 12, I want to know what the product of the functions would be. And so I'm just going to replace x with 12, and so I get the square root of 12 minus 3 based on the function that I had previously, multiplied by 1/2 times 12 plus 1. So in this set of brackets I get the square root of 9, and in this set of brackets I get 1/2 times 12, which is equal to 6, plus 1, which is equal to 7. That gives me 3 times 7, which is equal to 21. So what that means is if I'm looking at x equal to 12, then the product of the two functions will give me a result of 21. Okay, let's look at the next part. So in part C and part D, you're asked to sketch the graph of f times g of x. And then in part D, you're looking at the domain and range of f times g of x. Now the problem here is that if I try to graph this, there's no simple way of graphing this. Essentially what you need to do is graph each of the functions and then use the graph of each of the functions to help you graph the product of the functions. So let's start by graphing the root function. So I know there's been a horizontal shift to the right 3 units. So this is the base root function just shifted to the right 3 units. So I have a point at 3 and 0, and then I'm going to go over 1 and up 1. I'm just going to follow the trend of the root function to graph this. And that's pretty much all I can get in this graph. So I'm just going to sketch the graph there. So there's a root function. Actually, this point is not right. Okay, it's important to make sure you double check your work since you are multiplying the y coordinates, so it's good to make sure you check your work. And I noticed that I actually made a mistake. That point should have been there, not over 1 unit, so it should look like this. That makes a little bit more sense. Okay, and the reason why I knew it didn't make very much sense is because the graph looked a little bit too narrow, and I knew it shouldn't have been too narrow like that. Okay, let's graph the linear function. So this is a linear function that has a y-intercept of 1 and a slope of 1/2. So I'm going to plot the point at 1, and then I'm going to use the slope to help me plot more points. So rise 1, run 2, rise 1, run 2, rise 1, run 2. And I'll continue doing that, and I'll sketch a linear function. I need my ruler to do that. And so this is the graph of the two base functions. Now what you'll notice is that the root function starts at 3 and continues towards the right. So what that tells me automatically is I can't combine any parts of the graph of the linear function with the root function that go below 3. Okay, so I'm really only going to focus on values of the domain that are greater than or equal to 3. Okay, the root function doesn't exist below that, so I can't actually graph it below that either. Okay, so I'm going to start by combining the first value of x that I can, which is x equal to 3. And so what I'm going to do is I'm going to multiply the x values together. So I have an x value of 3, I have an x value of 3 here. So I'm going to look at what the y values are, and I'm going to multiply the y values together. So I have y equal to 0, and y equals about 2.5. So 0 times 2.5 gives me 0. I think I'll do this with another color so it's easier for you to see. Okay, and then our second point, I have a x equal to 4, y is equal to 1, and y is equal to 3. So 1 times 3 is equal to 3, so I can multiply those two numbers together. And then here's another good point. Again, try to look for pretty decent points to work with. I have x equal to 7, and so my first y value is 2, and my second y value is 4.5. So 2 times 4.5 gives me 9. And that's pretty much all I can really graph here, and I feel like the graph will end up looking like another root function. Okay, so that's what the graph will look like essentially. So this is f times g of x, whereas the other graphs were g of x here and f of x here. Okay, so looking at this graph, the only part of the domain that actually overlaps are values of x that are greater than or equal to 3, and that's because there was a restriction on one of the graphs that requires the same restriction to exist in the product of the functions. So in terms of the domain, I have x is an element of all real numbers such that x is greater than or equal to 3. And in terms of the range, again, in this case, if we look at the range values, we can't have any values of y that are less than 0. And you'll notice that the reason why that's happening is because the root function doesn't have any values of y that are less than 0. So the smallest value of y that I have is 0, and all the other values of y are greater than that. Okay, so there's the domain and range of the function. There are restrictions on it, mostly because there were restrictions on one of the functions, which created a restriction on the final product of functions as well.